Assalamu alaikum guys, welcome to my YouTube channel Analytical Chemistry. I hope that you all are doing good. So guys, and I also hope that you have already watched my previous videos which are on the atomic absorption spectroscopy, atomic emission spectroscopy, and my third video is on the advantages, disadvantages and the applications of the both emission and absorption spectroscopy. So if you watched it, then like and subscribe my video, don't forget. Okay, so let's start our new video which is on the very important topic of the analytical chemistry, including the flame photometry. Now let's see what is the flame photometry. During 1980s, Bowlings, Barnes, David Richardson, John Barry and the Robert Hood developed an instrument to measure the low concentration of the sodium and the potassium in a solution, and they named the instrument as a flame photometer. Flame photometry is defined as the measurement of intensity of light emitted when any alkali or earth metal is introduced into the flame. Because of the emission of the radiation, it is also known as a flame emission spectroscopy, and based on the element present in the sample, it produces emission spectra in different colors to the flame. Now the basis includes the wavelength of the color tells what the element is, which is qualitatively, and the color's intensity tells us how much of the element present, which is quantitatively. Now the principle of the flame photometry includes the compounds of the alkali and the alkaline earth metals can be thermally dissociated in a flame, and some of the atoms produced will be further excited to a high energy level. When these atoms return to the ground state, they emit radiation which lies mainly in the visible region of the spectrum, and here the main reason is after absorption of the thermal energy of the atoms which are present in the ground state will be excited to the high energy state, but it is not stable at all. It includes the ground state, de-excitation, excited state. Okay. And the important thing is the flow chart of the steps involved in the flame photometry include from nebulizer it goes to the sprays, including the dissolution where the solid gas aerosols are volatilized, including the gaseous molecules, and the dissociation of them into the excited molecules which goes to the atoms. In the excited atoms further goes to the ionization of the atomic ions in the excited atoms. So now one thing is the instrumentation of the flame photometry. The sample is introduced into the flame where it undergoes a number of processes leading to the formation of the excited atomic species which emit the radiation. The radiation is then measured and suitably analyzed. The instrument used for the purpose is called the flame photometer, and it consists of the following basic components. First one is the flame atomizer. It converts the sample to the excited atomic species. It consists of following, including nebulizer and mixing chamber. It means of transporting a homogeneous solution to the flame at the steady rate. Atomizer burner. Here the fuel and the oxidant burn to give a flame that can be maintained in a constant form and at a constant temperature. Monochromator of filter. It isolates the light of the wavelength to be measured from that of the extraneous emission. And detector helps in measuring the intensity of radiation emitted by the flame, and the amplifier and readout devices is used to amplify the signal and provides a suitable output. This one is the overview of the flame photometry, including ions in solution. Here it goes aspiration, aerosols, then vaporization in the flame, including molecules, thermal dissociation of the ground state atom, then heat energy absorbed goes to the excited state where heat energy emitted as a light and back to the ground state. This one is also the diagram of the flame photometer, including flame, burner, mixing of chamber, atomizer, sample, lens, slit, filter, photodetector, amplifier, compressed air supply, compressed fuel supply, and LCD display. Now we are going to discuss the applications of the flame photometry. It is used in the various industries like chemical, soil, agriculture, pharmaceuticals, glass, ceramics, in plant materials and water oceanography, and in biological and microbiological laboratories also. First one is it is used in the determination of the potassium, sodium, magnesium and so many other things, and is routinely carried out by a flame photometer. And it is also used to estimate the sodium, potassium and many other samples, serum, urine, CSF and other body fluids. It is also used in determining The concentration of the sodium and potassium ions in infusion solutions such as NaCl solution, Ringer solutions, and many other things. Product control indirect quality testing of the various substances including sodium, potassium, lithium, and the concentration determination in the pharmaceutical reagents. And in the production of blood collection tubes, the finished products are checked for correct chemical composition. It is also used in determination of the certain metals like lead, magnesium, petroleum, gasoline, and the flame photometry is useful for the determination of the alkali and the alkaline earth metal. It is also used in the determination of the lead in the petrol. Further, it is used in the determination of the calcium, magnesium, and so many other things in soil. So these are the basic applications of the flame photometry, guys. If you completely understand it, go and watch it completely and like my video. Don't forget to subscribe it and wait for my another important video on another important topic of the analytical chemistry which helps you a lot. Allah Hafiz.